to share with you my thoughts regarding the title of my talk, which is "You can go everywhere, but I can go fast." I found this analogy that the apps are like cars. They are designed for specific purpose, and if you ever faced a car choice, you probably know what I'm talking about. The type of vehicle is picked depending on your needs. And because I need a decent amount of space inside my car, because I have a wife and 2 children, I usually end up with a car on the right, an off-road car. It's cool because it has many features included, it gives me a lot of flexibility, and actually I can go everywhere I want. On the other hand, I also love speed and always dreamed about having a hypercar. So I start to think what could happen if I put an engine from a hypercar to the car that I use on the daily basis. So let's consider that case for a moment. The first thing I would probably do would be to take that car to the straight line to set up a new speed record. And I would probably feel a big difference in acceleration, making a big wow each time accelerate. But when emotions go down, I probably will realize that there's still someone faster than me. Furthermore, changing rules of the game by competing on racetrack with turns doesn't improve the result. The things might get even worse. And to check why, we need to take a closer look on how hypercars looks like, because they have a wide body, wide streamlined body, big wheels and brakes, and low center of gravity. There are also some design aspect behind the hood that people who designed hypercar need to think about carefully, and before even hypercar was produced. Because I said that the mobile applications are like cars, let's answer a question. What can we do if our application is more like an off-road car, has a lot of features, but not particularly good in performance in regard of speed? My name is Jakub Binda. I'm a software developer at ColdStack, passionate in improving app performance. And let me guide you through the list of possible modification with the context of React Native application to close our hypothetical application as much as possible to the hypercar and see where those divagations take us. The first possible modification that I would probably start with is a weight reduction. In the world of automotive, we basically want to remove all of unnecessary parts from interior as well as from exterior. Or if it's not possible, we need to find a lighter replacement. In terms of React application, we actually can do the same because we are able to do size reduction of the bundle by removing dead or legacy code, avoid bundling heavy JSON files. The example is the JSON files with the translation, because they can be handled in different way, and also keep our node modules clean by removing third-party libraries that is not used, or seek for its lighter equivalent. In one of my previous assignments, I was able to provide a benchmark and compare the script download and execution time in the baseline project in comparison with the blank React Native project. As you can see in the table, the difference is quite huge because it equals 2.3 seconds. And it's pretty obvious because we want in our application to put a feature to the end user, and because of that feature, we need to attach additional code, additional logic. However, this number can also tell us that there is a room for improvement and optimization. And actually that was the case in this project because I was able to reduce the bundle size from 28 megabytes up to around 15, and it has an impact on script download time, which improved by 26%, as well as script execution, which improves by 10, and the final TTI improved by around 13%. Another important aspect on car design are how the power from the engine are transferred to the wheels. In this chain, we have different components that is quite sophisticated, and because of that, there are some power losses in that chain. So it's not possible to have 100% of power from the engine on car wheels. In the same way, in React application, we have the components that should be presented to the user. And to achieve that, we need to consume some of the resources from our device. That's why the components should be as light as possible and render only a required number of times to prevent too much resources lost. And one kind of component that I found to be very problematic are the shimmers. The shimmers looks, for example, like that, and its purpose is to improve UX by making an impression that content in the application appears faster than it actually does. 4 of my previous projects that I had the chance to investigate, however, shows me that the reality related with the shimmers are slightly different because the shimmer were complex and heavy, and also the implementation seems to be over-engineered. I start to profiling the application with the Flipper plugin, with the Flipper profiling tool, and in result achieved the flame chart for that shimmer. And as you can see, that's how the flame chart for that shimmer looks. And I was able to notice that the render time for that particular component equals 132 milliseconds. And this is the value that is very close to the value that human eye can actually notice. So there might be some flickering occurs during rendering that shimmer. The underlying reason was connected with using one of the existing library to create shimmers. And because in that particular use, most of the logic delivered but that library wasn't even used, then the component becomes too heavy to its use case. The solution was to provide a lighter version of primitives for the shimmers and avoid need to execute additional logic. The final score of render time equals 36 milliseconds, which is 4 times better result than before, and also the structure of that shimmer were simplified. Using a flame chart and profiling tool from Flipper, it's a very nice tool that you can use not only for the shimmers, but actually for whatever component in your application that you want. Okay, so let's talk about the airflow over the car. Streamlined body allows to reduce the turbulences behind the car. However, in case of our off-road car, they might become a serious issue and stop us down from reaching the top speed. I like to think about those turbulences as an unexpected render in React Native application. And if we are talking about the renders, I need to mention about the component structure, because the structure defines the correlation between components and also a sequence of rendering. When the component structure becomes complex, and too complex actually, it might lead to longer render time and more resources consumption from our device, as well as more re-renders. So I again utilize the profiling tool from Flipper, and during one of the investigation noticed something like that. I used to call this pattern as long tails when some part of the component structure are much longer than the neighborhood of that structure, and in this case there were 38 components, and also much of them has its internal state, which actually cause the additional render. I was able to move out that internal component state to higher component, but also I was able to reduce total amount of the component, and the final result was that the component in the same structure were reduced to 20, and this is how the final structure looks like after the modification I mentioned, and also I were able to prevent 3 unexpected re-render in the current case. So again, flame chart and Flipper profiling was extremely useful to provide and allow to spot that weak point in the application. Another important aspect in car design are the tires. The tires are the only part in your car that actually have contact with the road. So that's why I like to think about React hooks about like the tires in your car, because they allow to communicate component with the rest of the application by, for example, triggering the side effects. And despite the fact that the support of them in React Native were introduced in March 2019, I still feel that implementation of some of the hooks are problematic in terms of performance, because improper use might lead to unexpected render when their value change, and also when the dependency are not set correctly. Also, they might lead to increased resources consumption if their logic are too complex, or the consumer of the result is hidden behind the flag. So one of the example from my experience was noticed in the flat list base screen, which allows user to scroll the content, and some part or some rows of that flat list and some part of the component tree in that rows gets additional render, even though those components were not visible in the device viewport. So again, utilizing the Flipper flame chart and profiling tool, I was able to spot that situation and also figured out that there were one underlying hook that caused one of the property change that when passing down through that structure caused some part of that tree to render. And the final result after, because I was able to move that logic away from the row of the component and pass the same prop in different way, I was able to achieve this component structure. So as you can see, there is no additional render for the same part of the component tree, providing the same scrolling and the same method of measurements. During this investigation, I also used another cool feature included in the Flipper, which is called React Native Performance Monitor plugin. And thanks to that plugin, I was able to measure that before my change, the performance score was at 80 points with 37 average JS FPS, and after the result, the measurement shows that the performance score increased to 95 points, and also there were 55 JS FPS on average. So I encourage you to use that Flipper extension in your app and make a lot of profiling across your app. And the last modification that I would like to mention is connected with the selecting drive mode. If you want to compete on a racetrack, you would likely have sport or race mode selected to get the best from your car and achieve the best result. At this point, you wouldn't be surprised if I tell you that we have a similar option in React Native. We as a developer, most of the time, working in the development environment, so each time we develop an app, we have a development build as well for the native or React Native sites. However, it's highly recommended that for your measurement, you should use the production version of the app, which is released version of native site as well as JS site. In one of the projects, we grabbed the measurements to benchmark the differences between those environments. And it was a brownfield setup, and we measured the app start of the native app as well as how fast the React Native screen can show its content when invoked from some place of that brownfield setup. So in the first case, both development builds, and here's the result of that measurements. The next attempt keeps the development build on the native side. However, we use the release bundle, and as you can see, the required number of time to show the React Native screen increased twice. And the best result we achieved by using both release built on native side as well as in JS. And actually, the last column proves why it's highly recommended to make measurements in the production environment, because then you have the most similar experience that your end user will have. However, it's still possible to provide measurements on development. However, more in terms of the benchmark, after you provide the same measurement step, and after you notice that your change improve the number significantly, then you also might assume that it will be also noticeable on the production. However, still, it's better to double check that. So at this point, we can jump and try to see what potential effect we were able to obtain. As you remember, we started with the presented off-road baseline and wanted to be as close as possible to the hypercar. And probably the modification I go through and all of that effort requires spending a lot of time and maybe a lot of money. But in the end, we might end up with this kind of monster. And guess what? I really love it. I think it's super fast and should bring a lot of joy while driving. However, it also has some drawbacks. It seems to be pretty loud, and we also lost some of the flexibility comparing to our base. It also doesn't look like a hypercar, right? So the question is, should I bought a hypercar straight away instead of wasting all of the effort and money with the discussion modification? No, I don't think so. And the conclusion from that story is that everything is possible, but not always cheap and straightforward. You need to take into account that it's much easier to put a proper design first place than addressing missing design principles in existing architecture. That's also the case when performance is afterthought. Also, your end user might not desire the top speed. They might be more interested in having enough fast car to drive comfortable, but have more flexibility on the other in the same time. So I believe the key here is balance between flexibility and performance. Okay, so the key takeaways are provide a stable and reliable method of measurements for your goal, because then you will be able to trust the number you measured. Set up a baseline to compare the final result. It allows you to track your progress. Be methodical and think outside the box, because each project has its own specifics. Don't hesitate to achieve quick wins, because they really matters in the end of the day. And use a holistic approach, but pay attention to details, because then you will receive the best results. And out of these 5, the last one I would like you to remember most, because people tend to either use holistic approach or pay attention to details, but both of these are required to create a great app. Good luck. Thank you.